Suppose you understood this. Now similarly, just like gravitational field, there are so many properties of Earth. Because of the mass of Earth, there is gravitational field, and this pen also has got mass. A massive body experiences gravitational force in gravitational field. Now, similarly, assume that, see, now think, there is something called object. Now, to the object, you can give many properties. So, now think that there is an object. You give a property called mass to it. You give a property or identify that there is mass in that object. There are many other things, but right now the context is this object has got mass. Then our science starts. Like this. Consider an object. Consider that this object has got mass. Our science has started. Now, because of mass, what is there? Good. There is gravitational field. And what does gravitational field do? Listen, that is the problem. Now, just you see, because of gravitational field, another mass in that field experiences gravitational force. Attract, whether it repels, that is secondary. So, another mass experiences gravitational force. Now, let's take one more part of the problem. Consider an object. Can you consider an object? Hello, everybody there?
Yes.
Say yes, online students also. Come on, if you are not convinced, you should tell. You should tell, sir, I am not understanding. Spot, don't think. You don't think. You just tell me, sir, I didn't get it. Please repeat. I will repeat. I have got tons of patience. I am a teacher. Right. Consider an object. Did you consider?
Yes, sir.
What does this object have?
Mass.
Did I say so? So you are not alert. All objects will not have mass. So for Aryan, how can there be an object without mass? See, this is science. You got to assume some things, you got to presume some things, and you got to move forward. You cannot say everything, show me. Then only you will see those things which your eyes cannot see. I am making you to see those things which your beautiful eyes cannot see. And there are those things. There are many things. See, around you there are so many bacteria, virus. Can you see? No. But do you believe they are there? Because you have got so many sickness and disease. Right. So, consider an object. Did you consider an object?
Yes, sir.
What does it have?
Some output, some good.
May or may not be. May or may not be. Okay. Whether it has property or no is not to be considered. You just see there is an object. Now, to that object, if I say it has mass, then you will say it has around it there is gravitational field. And then in that gravitational field, if you bring another mass, that experiences gravitational force. That's it. Okay. Now, watch my words very carefully. Now, consider the object. What does it have? Nothing. Now, consider it has got charge. Okay. What is there around this? Electric. Good. Now, you know what is this in my hand? What is this?
Object.
Now, when I am showing you this, why are you telling it is object? It's a pen. Understood? Object is hypothetical. What is this in my hand?
Pen.
One property is definite in that. What is this? It has mass. Sure. So, consider an object which has got charge, and then I am bringing this pen. So, because this object has got charge, there is electric field. And now if I bring this pen which has mass, only mass, here, what happens?
Nothing.
Louder.
Nothing.
Nothing happens. Because the electric field will not affect the mass. Clear? Now, supposing this is glass rod, I have rubbed it with silk. Then this object has got charge. It has got electric field. Now, if I bring this pen which is charged, what happens? It experiences electrostatic force. Good. That is the way to answer. Got it? Understood? Now, consider an object. What is there in the object?
Charge.
Nothing. Unless I say so. See, that is what I am telling you, students. When you say something in physics, it should be complete and unambiguous. Unnecessarily, you should not assume. If you say assume, then it is there. Otherwise, it is not there. But some things, like if I show you pen, obviously it has got mass. If I say there is an object, then it may or may not have mass. Got it? Be open-minded. Right. So now I have got an object. What is there in the object?
Nothing.
Now in this object there is mass also, there is charge also. What did I say? Now if I bring this pen here, what happens? It experiences gravitational force. Now I will charge this pen. There is an object which has got mass and charge. And because of mass and charge, what is there?
Electric field and
This boy is telling the right thing. Electric field and gravitational field. Now I bring this pen which is charged here. Now what will happen to this?
It experiences both gravity.
It experiences both gravitational field and electric field. Understood now? Now now that's what I say. We physics students have got Divya Drushti. What did I say? Divya Drushti ana? Divya ana? Divya Drushti means something you can see beyond and beneath. That is Divya Drushti. So, an ordinary eyes cannot see, but you can see. Now start seeing those things. When I say there is electric field, when I say gravitational field, you start seeing the vectors. When I have a positive charge, start seeing the vectors. How? Like this. Because it is going to push the positive charges. If you got this object with negative charge, start seeing the vectors like this. Electric field vectors like this. You can see. Decide to see, you can see. If you close your eyes and if you want to see somebody, you can see now. Isn't it? So like that, start seeing the electric field. Clear? Okay? So why I am stressing so much on these students is because, see, the entire electrical phenomena that you see is because of electric field. The entire electrical phenomena, be it lighting or this tube light is on, my camera is working, fan turns, whatever you see, even these atoms are held together. There are millions of atoms. They are held together because of electrostatic forces. All that chemistry you are learning, the molecules, atoms combine, they form molecules. What is binding the atoms? Electrostatic force. What is binding the molecules? Electrostatic force. Of course, you will learn more about it. You will learn it under the heading called electromagnetic forces. Clear? So that is very fundamental, students. Very, very fundamental. All these things that are bound around you is because of the electromagnetic forces. Understand? So, therefore, it is very fundamental force. You must understand it properly. Then you will understand bhandar of science. Physics, chemistry, you will understand every aspect of it. And you will start using mathematics to understand physics and chemistry. You will start using mathematics to understand physics and chemistry. When you start using mathematics, you will start appreciating mathematics. And when you start appreciating mathematics, you will learn more of mathematics. So physics, chemistry, mathematics are interlinked. Now take your biology. You have a plant, a tree, its roots are on the earth. But you see all the leaves are green, they contain a lot of water. How will water get transported from the root to the plant? There is lots of physics there. There is lots of physics there. The working of your body, there is lot of physics there. There are electrical signals flowing from your head to the heart, to all the parts of your body. There is electricity there. Electricity means electric field is there. It is very complex. So if you understand these fundas in your high school, then you will understand much better in PUC 1 and 2. And trust me, whatever professional field you take, you will be experts. Otherwise, you will be very good. See, you will all get good jobs. But you had the potential to come up here. You had the potential to come up here if you had learned properly. Since you don't learn properly, you will come up to this level. You will not come up to this level. And when you come to this level, the capitalist, Americans, Chinese, they will use you. They will nicely use you because they want people at this level. If you are at this level, then you will dislodge them. You will become a competitor to them. So they will not allow. This is how the education gamut is working. They are keeping the education system low since British time, so that you don't rise up. If you rise up, you will challenge them. So it's a well thought of idea. That is why your examination question papers and all are very, very weak. Teachers will not take the challenge of teaching the children. They are wonderful teachers because they are afraid. If my students don't score well, then they will not come to my school. They will not come to my tuition. I should ensure they get good marks. Whether they have knowledge or no is secondary. But they should get good marks. Today my child is crying, give them chocolate, it will be happy. Tomorrow its teeth will go to dogs, it will become unhealthy, is not my problem. Because when the child becomes sick, the child will not be in the school. Because you will become sick after PUC 2. You will not be in your school. You will not be in my tuition class. So after 3 years, you would have forgotten everything. You will not come back and scold me. Today, if something happens, tomorrow you will come and fight. But today something happens, after 3 years, are you going to come and fight? No. So that is how everything is working. So don't fall prey to that. Take it. It is difficult, but we should be tough enough. Okay, so electric field is very, very fundamental. Understand? It is difficult to understand. I am not saying that, it's very easy. And if you are not understanding, you are not dull students. You are wonderful students. If you can tolerate Sudheer Murthy for so many classes, you are really wonderful students. I am telling you the truth. You cannot tolerate me unless you are good students. This is 100% sure. Since you are tolerating me, and I am not giving you good marks. See, when I was teaching in BUB college, they used to show the average marks scored by every student, all the classes in the test. Even her aunt was my student. So 25 marks, the college average, the most of the teachers, the students would have got 24 out of 25. So the class average used to be around 23. But in my class, the first test average used to be 11. And that was the lowest. In there are 25, in the whole college there are about 60 different classes. So each class has average marks in the test as 23, 22, some 24. But my average used to be 11 in the first test. Okay, then there should be feedback from the students. After test, they take feedback. So a teacher is evaluated. How does he teach? How does he behave? How does he show the board work, etc. So students will give marks. So in that feedback, I used to get the highest. Even my marks was lowest. Second test, the class average used to be 19. Third test, the class average used to be 22. Because my students used to take the challenge. This fellow will not give marks. I have to earn. And my internal marks is going to change their destiny. Understand? But now I am not giving you marks. So some of you are taking me for granted and light. Take me seriously. In my test, try to get maximum marks. Take it as a challenge, Purusharth, and at least for that you do. Huh? So now I suppose you have understood electric field and gravitational field. Okay, shall I proceed? Now, what creates electric field? Now I told there is charge and there is electric field. Agreed?
Yes, sir.
Now, what is the relation between charge and electric field? If more charge, will there be more electric field? If less charge, will there be less electric field? If there is charge and if I move away from the body, will the electric field decrease or increase? Will the gravitational field decrease or increase? That is what we are going to slightly investigate. Okay? Now, what is the difference between electric field and magnetic and gravitational field? Gravitational field will attract bodies with masses. Electric field will attract objects with charge. Sorry, it will experience force because it can be attractive or repulsive. Then another important difference is, you see, now supposing now I will create a concept called point charge. What is it? Point charge. So what is point charge?
An extremely small object.
Very good. See, this boy is doing good today. Thank you. Extremely small object. First you consider extremely small object. Can you consider? Almost a point. Then what is the point charge?
Which has a charge.
You give charge to that. How much charge you want to give? Point mass. What is point mass?
An extremely small object.
Yes, good. Aryan is also telling. Extremely small object, and you can give any amount of mass to that. You can give 1 gram or 1 ton. It will take. So you create a point mass. Point charge, point mass. This concept is extremely important. Okay, now please try to understand. See, why we are developing these things is, see, you have all studied optics. When I first studied optics under me, okay, I did something like this, right? I took a concave mirror and I took the concept of one dot. What is this?
Point source of light.
Excellent. I took the point source of light, and then of course if this is focal point and this is center of curvature, then where is the image of this? Somewhere. This is the object, this is the image. Now you see, this is conceptual learning. Then I took what is called as this object, called it as AB. Now what is AB?
Point object. Extended object.
Extended object. What do you mean by extended object?
It's this object has a very small point.
Excellent, brilliant. Today this fellow is doing fantastic. Excellent. Everybody should do. Extended object. See the word extended object is not a proper noun, correct? It's a creation. Means it is extended object contains many points. Why did we do this? Because whatever theory you develop for this point object, you developed a theory, how the image is formed. Now the same theory will be used for this point object. The same theory will be used for this point object. Understood? So you see, if I am able to get the image of this here, okay, then, and this is perpendicular, right? This is perpendicular, and what is the science that we have learned? What is the distance in optics? What is the object distance of this point, and what is the object distance of this point?
It's equal.
Is this more than this? Is this object distance of this point is more than object distance of this point charge? Of this point?
They are equal.
They are equal. What is the theory that we developed?
Like it is almost the object distance.
No. That is not the theory. Good. That is not the theory. Tell.
Object distance is calculated with respect to principal axis.
With respect to principal axis means what? From the pole.
So the object from the pole.
Yes,
The object
you-
distance from the pole is equal to the all the points on the object.
Excellent. So you see, this point object has also got the object distance is u. For this object also object distance is u. For all these objects which are perpendicular, the object distance is u. Based on that, we have developed the theory. Now Aryan is confused. How is it possible? So in the PUC first year, you will start with this assumption. Otherwise, you cannot if you want to say these distances are different and solve, then you need higher mathematics. Things become complicated. So the easier way is this. Now listen, students. Here, when you are learning PUC 1 and 2, we make idealization. We make some idealization. We start with idealism. Okay, life is like that. Good person, bad person. In between, you have some people. Who are those people? Real people. Rama and Ravana. Two different characters, opposite characters. In between, all of us are there. Sudheer has some Ravana also, some Rama qualities also. Understood? Understood all of you?
Yes.
So that is reality. All of us are between these two extreme points. Now our studies in fun high school and PUC first year is either Rama or Ravana. Now as you learn further, you will start taking all the other possibilities and create the reality. Understood? So therefore, this was the assumption we did, that all the object distances are same. And so now, if the image of this point is here, then obviously the image of all these points must be along this, because the object distance is same. Hello? So if you are able to find the image of this object here, then the image of this will simply be this. You don't have to go on drawing ray diagrams for every point. That is the concept of point object and extended object. Got it? So now be aware about these basics that you have learned to develop the theory in optics. These techniques will be used somewhere else also. These techniques will be used somewhere also. So similarly now in electricity, we are creating a point source. We are creating a point source, Q. Usually we use the word Q. Traditionally it has been used, I am using the word Q. Okay? So what only thing is, when I write a point charge and say Q, it means it is positive charge. If I don't write anything, it is positive charge. If it is negative charge, I will write this. Understood? That is how we begin. So now I'll take you to the diagram. So in this diagram, you see many things. Now you can see that there is. This is just a water. Now see one by one. Don't see other diagrams. Whatever I am showing you. So here you see water getting filled. So I am Q in stands for the amount of water that is falling. Amount of water that is falling, right? Quantity of water that is falling. So as quantity of liquid increases, the pressure at the bottom is increasing. I hope you understand this.
Yes.
What is the pressure at this point?
All the water.
What is the, do you know for rho GH? You know that? Rho stands for density. Density of the liquid. G is the acceleration due to gravity. H is the height of the liquid. Height of the liquid. Rho GH. Rho stands for density. So the pressure here is rho GH. Now you see here, rho is what? Density of water. Here, if you are using water. G is what? Acceleration due to gravity. That is also constant. H is what? Height of the liquid. Now, so here in this case, the pressure here depends upon the height of the liquid. These two are constants. Got it?
Height of the liquid means in the container is how high it is.
How high? This is man. Height means from this point to this point. That is the height.
Yes, sir.
Got it?
Yes.
Height of the liquid. Got it?
Yes, sir.
Rho GH. So as the height increases, the pressure increases. Clear?
Yes, sir.
Now, please appreciate. Supposing I have a bigger container. Okay, and I have got one container which is small and one container which is big, large, diameter is large. But the level of water in both are same. So what is the pressure at the bottom?
So in the small container pressure is more.
In small container pressure is more.
Even in the large container
It is less. Why? See student, that is the problem. See, you didn't appreciate what is the equation I told. I told pressure at the bottom is what? Rho GH. No? Did I say? Hello?
Yes, the
See, I told what? This is the container and this contains water. Correct? Huh? The height of the water is h. The density of the water is rho. The acceleration due to gravity is g. The pressure on the bottom. The pressure on the bottom anyway is rho GH. Now density of water is same. Constant, G is constant. So the pressure depends upon height. Now I will take a bigger container. Rho stands for density, man. You don't know density? Symbol for density. See, I am using these symbols because I want you to read H.C. Verma, Concepts in Physics by H.C. Verma, before you finish your 10th standard. If you are able to read that at least few chapters before you go for your 10th standard examinations, then you can think of doing NEET and mains. Otherwise, you will still do mains and NEET. Not that you will not attend the exam or so, but you will get less ranks. You will not get very good colleges. You cannot go to IITs, you cannot go to AIMS, you cannot even go to KIMS. I want you to learn. They are using all these symbols. And I have seen students in 8th standard started reading the H.C. Verma. Don't worry, you can at least read 2 chapters. I will make you. But good that you asked. It is a symbol for density. Right. I am taking a bigger container, Aditi, and now the level of water is same in both. That means height is same. So what is the pressure here? Pressure here is rho G. H is same in both. So the pressure is same. Now what was your confusion? Why did you say like that? Don't worry. I want to correct that mistake that is there in your mind. Tell me, why did you say?
the surface area, I thought.
Now, what has happened to you people? I tell you. In your 8th standard or 9th standard textbook, they had given a brick. They said there is a brick which is standing like this, and the same brick is like this, and the same brick is like this. That is, they are keeping the brick like this. Vertical, like this, and like this. In which position? And they had asked a question. This is A, B, C. In which position the pressure is maximum? You all wrote A. Hello.
Yes, sir.
Hello. You all wrote A. Hello.
Yes, sir. Yes, sir.
Yes, sir.
And so, with that in mind, you are answering this. Now, what you didn't understand there is, what is the pressure? See, you only wrote like that. But what is the pressure here? Pressure here is the weight of the object divided by the area. This area. Correct? Hello?
Yes, sir.
Now the same brick, the weight of the object is same, but the area becomes A dash. A dash is more. Here, the same weight, area becomes still more, so it is least.
Yes, sir.
Pressure is least. Pressure is more. Pressure is most.
Yes, sir.
That's what it is. But here you see, the amount of liquid here and the amount of liquid here is different, is it? Is it the same?
No, sir.
See, in all these three cases, weight was same. Here,
Amount of water.
that is one difference. That is one difference. There is one difference. But that is not the way that is not the way to look at it. Okay. So now you see, students, this formulation when you did, there is a way of actually determining this. That's what I'm telling you. If you know how this formula has come, okay, this formula has come based on a lot of science of the fluid at rest. Science of fluid at rest. You have studied buoyant forces and all, but you have totally forgotten. Because you never learned, you have studied fluid statics. You have not learned fluid statics. If you had learned a bit of fluid statics, then you would have come across this equation. You have come across this equation, right?
No.
That means you are not taught well. Fluid static means this, yes, you said no?
Yes.
Only this girl has learned.
I have seen it like in many sums and all.
Sums and all. So they had asked directly in numericals. They are not explained in the class, but they had asked questions in the numericals in your school or somewhere at that level.
No,
Where?
school they didn't give only like density and all. What is the
Relative density and density.
Relative density you have studied means you should have studied. That is a higher concept. Okay, it's okay. But you are supposed to do this. Alright, now did you understand? So like that it is there. So therefore now Aditya it's okay. Huh? But what I didn't like in you is, when I told you this, that the pressure is rho GH and rho stands for the density of the liquid, G is the acceleration due to gravity. So the pressure under this circumstance depends upon the height only. Then if I had asked, then I asked you, did you understand? Then when I asked you this situation, you said the pressure is less here. You did not appreciate this equation. So your intensity of learning is very, very less. You have got to improve on that. These are all the small mistakes that you are doing. Just improve on that. You will do great. Trust me. Small things in life. Alright. So, you see students, I am doing my best to bring the science behind this.
So that formula rho G is only to find the pressure at the base, no, so not at sideways.
Not at?
Sideways.
Okay. This boy will go into this. Right. Now, you see here, I am going to draw a hypothetical line. Now all of you listen. Now this pressure is same at this point, this point, this point, and also this point. The pressure is same at all the points, if that at the same level of the liquid. Got it? Hello?
Yes, sir.
Understood?
Yes, sir.
So the pressure here is also same as the pressure here. Did I answer your question?
Yes.
Then you say yes, no, you are not showing anything, you are sitting like this. Yes also, no also, what should I do? Come on, tell, did you understand? Be happy, at least show that happiness at least on your face. Please. Okay, done? It is this. Okay, shall I continue? Yeah. So the pressure here depends upon the height. Do you understand?
Yes, sir.
Okay. Now, here I am giving you a sphere and it has got mass here. Object has got mass here. So what is there at this point P? And see, P is a point, some point in space. At this point, what is there? That's all, gravitational field. Understood?
Yes, yes, I know.
Louder.
Can I sit there, sir?
Anywhere except my head. Come. All of you are comfortable?
Yes.
So what is this? This is an object which has got mass. Now is it clear?
Yes, sir.
And around the object, what is there I said?
Alright.
Now I am coming to the next level. How much gravitational field? So I am choosing some arbitrary point P. How much gravitational field? At a distance r from the center. It is G. G is universal gravitational constant. M is the mass of this object. And R stands for what?
The distance between the object and the point.
No, wait a minute. I am not explaining gravitational field here. I am explaining gravitational potential. Sorry. I'll tell you the difference. So here the gravitational field at this point will be Gm by R square. Gm by R square. Okay? Gm by R stands for the gravitational potential. I'll come to that later. There are two things. One is gravitational potential, another is gravitational field. Now we are talking about gravitational field. So it will be minus Gm by R square will be the gravitational field at that point. Right? Hello, are you with me?
Yes, sir.
So the gravitational field at this point will be Gm by R. R stands for what?
Distance between the object and the point of
From its center.
From the center of Earth. This is P. This P, point P here, is the distance of this point P from here to the center of Earth is R. Got it? So R is from the center, not from the surface. Understood? So minus Gm by R square is the gravitational field. That means now you see, R increases, the gravitational field will decrease. The magnitude will go on decreasing. Got it?
So it is negative because
Wait a minute. Negative means it is attractive. Negative means it is attractive. That the mass will get attracted. Got it?
Can you repeat what it is? If R increases,
The magnitude of the field will decrease. Magnitude of the field will decrease. It is minus Gm by R square you must take it. Hello? Are you with me?
Yes, sir.
R square. Point number 1. So that means now as R increases, the magnitude of the gravitational field will decrease. You see that no, as you go further, the gravitational field will go on decreasing. Right. Now, at this point, there is gravitational field. Agreed? Now, you see, other day I told you, what is this? This is got mass M. So, now can you see a force pulling this?
yes sir.
Yes, sir.
Can you see a vector?
Yes sir.
Mg. What is Mg?
It is the gravitational force.
With which Earth is pulling. See, we'll use different words. It is with which is pulling. Now, what am I doing? That's why it is coming up. So I am doing work. Force into distance. So this work done is getting converted into what?
Energy.
What energy?
Potential.
Potential energy. So at this point, this mass has got potential energy. Supposing the height from this point is h. What is the potential energy? mgh. mgh. Now supposing this, so there is mgh. Now, if I keep the pen here at the same height, what is the potential energy? mgh. Everywhere it is mgh. Now, so what I do now, the potential energy of this pen at this point is mgh. I will divide this potential energy by the mass. mgh by m. What will I get? So now I define a new concept. What is the new concept? Potential. Potential energy per unit mass. Potential. Got it? That means now this point has got some potential. What is the potential at this point? GH. At this point, if I place a mass, it will have potential energy mgh. Hello, are you with me? At this point, the potential energy of the pen is mgh. I divide this mgh by m. Then what will I get? GH. And what is GH? Potential energy per unit mass. I am giving a new name to that. What is that name? Potential. So what is the potential at this point? What is the potential? What is the potential at all these points? What is the potential at this point? GH1 or GH dash. Understood? Understood all of you? This is near the surface of Earth where G is constant. G I have assumed it to be constant. Is that clear? So now you see students, I can say there is electric field here. I can also say there is potential field here. Both can coexist, like how you are son to your father and brother to your sister. Clear?
Yes, sir.
So at this point I can define it as electric field, or I can define it as potential field, or I can define it as both. Clear? Now when you come to PUC second year, you will do this derivation. The gravitational field at this point will be minus gm by r square. The gravitational potential field at this point will be minus gm by r. You will do this derivation. Got it? Hello?
Yes, sir.
Doubt?
So like r square, why we took r, like what was the reason for squaring it?
That is what. You will do the derivation. There is no reason. There is no reason. The great scientists, they experimented and found out. The great scientists experimented and found out that the gravitational field is directly proportional to the mass. The gravitational field here is directly proportional to this mass. Hello?
Yes, sir.
And inversely proportional to the square of the distance. Universal gravitational law, or the universal gravitational law says the force of gravitation is directly proportional to the mass. If this mass is more, the gravitational field here is more. And the gravitational field is inversely proportional to r square. That means as r increases, the gravitational field will decrease. In terms of r square, it could have been 1 by r. No, but scientists found out it is 1 by r square. Now, using this gravitational field, you can derive gravitational potential. What did I say?
Using gravitational.
You will have this derivation in PUC 2, in PUC first year, where you will derive this one, minus gf. So, what is the gravitational field at this point? Minus gm by r. What is the gravitational potential at this point? Minus gm by r. Now this minus sign, when you are talking in terms of gravitational field, it depends upon how you see it. If you are defined the unit vector in opposite, in this direction, radially outwards. If you are defined the unit vector radially outwards, then you will write minus sign. But if you define the radial vector inward, then you will write plus sign. Okay, now don't get confused. Okay, but that is how the sign convention works. That you will learn in PUC first year. Thamba. Okay? Right. So, did you understand gravitational field? Hello?
Yes,
Yes,
Now come to this object. What is this object? This is also object. Hey, it is not point. It's an object. Now, I have given the property of positive charge. So, around it you have got electric field. No, don't say positive electric field. Electric field. Electric field due to positive charges. But don't say positive electric field, that term you should not say. There is electric field. Now, here, what is the electric field at this point? The electric field at this point will be kq by r square. क्या बोला मैंने?
KQ by r.
kq by r square. That means the electric field depends upon how much charge is there and inversely proportional to the distance. That means if you go further away, the intensity of electric field will decrease. See, now you have got a agarbatti. You come close to it, you get tremendous smell. Then you start going away and away from it. The intensity of smell goes on decreasing. Isn't it? It's the same thing. Beside your school, there was a big tipi. Rotary school, isn't it? If you come closer to that, you would get suasni. Then you move away from that, then you would get, the smell would be less. Understood? Intensity decreases with smell. So here, the intensity of field will decrease with distance, inversely proportional. Same thing, just like how you had gravitational potential energy. Here you have electric potential energy. There you are picking the mass. Here in electric field you will pick up the charge. You consider an object in my hand and it has got charge, and there is an object here which has got charge. So pushing this up. See, there you have got mgh. So here, and this will have some potential energy. Here, that is gravitational potential energy. Here you will get electrostatic potential energy. And similarly, you have electric potential. Electric potential due to positive charge, electric potential due to negative charge.
The big Q over there is the charge of the object.
Charge that you have given to this object. Charge you have given to the object. Doubt?
No.
See, just like how I am pouring water here, I can pour charge. Just like how you are pouring water and increasing the pressure, I am able to pour charge and increase the potential. Got it? Now read this. So, as the charge of the body increases, the electrostatic potential of the body at P will also increase. Got it?
Yes.
Now, this is a concept that I developed here using object. Now, let's come to some reality. So, here you see I have taken a body like this and I have given a charge to this body, positive charge. On the surface of this body, the potential is V1. On the surface of the body, the potential is V1. Similarly, I have taken another body, I poured charge onto that. The surface of the body, the potential is V2. Minus V2, because I have given negative charge. Now, potential of positively charged body with respect to negatively charged body. See here. Potential of the positively charged body with respect to negatively charged body is plus V1. Now listen here. Minus of minus V2. That gives you V1 plus V2. Correct? And supposing V1 and V2 magnitudes are same, then I would have written here, this is plus V1, this is minus V1.
Yes, sir.
Then I would have got here V1 plus V1, that is 2V1. Now this is what happens in a battery. In a battery there are two plates.
What is potential energy with respect to?
Pardon?
Potential energy with respect to is what does it mean?
With respect to means, see, now, good question, good question. See, this boy has asked a really good question. Now this pen, if I keep it on the table, so if I make the table the reference point, hello, if I make the table the reference point, see now, we are choosing the reference is important. Now what is the potential energy of this, gravitational potential energy of this pen on the table?
MG.
GH.
There, what is it?
It's
Height from the center of
No, see, that's what, why did you assume height from, when I did this experiment, did I say height from the center of Earth?
No, sir.
See, this is one problem. You understood till now very nicely. Now you started, oh, I now know science, I can tell anything. Be cool.
it will be 0, sir.
So, with respect to this table, the potential energy of this pen is 0. Got it? With respect to this table, the potential energy of this is mgh. Got it?
Yes, sir.
Now, with respect to ground, if the height of the table is something like say k, then the potential energy of this pen on this table down here is mgk. But with respect to the table, it is 0.
Yes, sir.
Got it?
Yes, sir.
What is the potential energy of this with respect to the table?
0.
What is the potential energy of this with respect to the table? mgh. Now I will make this reference. Then what is the potential energy of this with respect to this point? I kept it on the table. Minus mgh. Got it?
Yes, sir.
Because you don't have to do work. Gravity will do the work. It will pull it. Here to lift, you have to do the work. You do positive work. Here you will not do work. The gravity will do the work. Therefore, the potential energy of this pen with respect to this point when I keep it on the table is minus mgh. If you take this reference, then it is plus. Got it?
Yes, sir.
Are you understanding?
Yes, sir.
Here.
Minus sign comes because it is height is opposite like that.
Because this is at higher level. Now here you see, you are doing work against gravity. Here, if I leave my hand, gravity will do the work. So it is minus. Okay, actually it is not like that. Shall I tell you? Are you able to understand?
Yes.
Now you see, the idea is, when I am lifting this, observe, when I am lifting this pen, its kinetic energy is not increasing.
Yes.
So all that energy I am putting is to only increase the potential energy. Therefore, its potential energy is mgh. See, now at this point, when this pen crosses this point, when it crossed this point, what are the potential energy? mgh. Plus, it also had kinetic energy. So its total energy is mgh plus half mv square. Now, when I am going to derive this expression in first year PUC, there is a condition mentioned. That is, this pen is moving at constant velocity. Its kinetic energy is not increasing. Then only its potential energy is mgh. All that work you do is getting converted into energy. Clear? Now you see the pen is here. So with respect to this reference, what is the potential energy of this?
0.
Now you see, I am going to pull the pen down. But here you see the pen is moving with uniform velocity. How is it able to move with uniform velocity? Gravitational field is acting down. Hello?
Yes.
But my hand is also applying force. Is my hand applying force?
Yes, sir.
Yes.
What is my hand doing? How much force is my hand applying? Equal and opposite to the gravitational field. Because if I leave my hand, this will accelerate.
Yes.
I am holding my hand, it is not accelerating. That means I am applying force to ensure that this will not accelerate. So work done by force applied by me is up, but the displacement is down. That is why the energy is negative. Force applied by me is in this direction.
They are also motivated down.
My tip of the finger is moving down. Displacement is in this direction, but force applied is in this direction. My force vector is like this, my displacement vector is like this. Therefore, work done is negative. And therefore, the potential energy of this with respect to this point is minus. Got it?
Yes, sir.
Don't worry. See, ಈಗ ನಾ ಏನು ಕಲಿಸೇನಲ್ಲ ಇವತ್ತು ರಾತ್ರಿ ಮಲ್ಕೊಳ್ಳೋಕ್ಕಿಂತ ಮುಂಚೆ ಒಂದು ಸ್ವಲ್ಪ ಒಂದು 10 ನಿಮಿಷ ಹಿಂಗೆ ಕೂತ್ಕೊಂಡು ನಾ ಏನೇನು ಕ್ಲಾಸ್ನ ಕಲಿಸೇನಿ ಎಲ್ಲಾನು ತಲೆಗೆ ಹಾಕ್ರಿ. ಸ್ವಲ್ಪ ಹಾಕೊಳ್ಳಿ. ಆವಾಗ ಡೌಟ್ ಬಂದ್ರೆ ನಾಳೆ ಕ್ಲಾಸ್ ಒಳಗೆ ಬಂದು ಕೇಳ್ರಿ. ಟುಮಾರೋ ಅಗೇನ್ ಕಮೆಂಟ್ ಆಸ್ಕ್, ಐ ವಿಲ್ ಟೀಚ್ ಯು. ಬಟ್ ನೀವು ನಿಮ್ಮ ಎಫರ್ಟ್ ಹಾಕ್ಬೇಕು. ಈಗ ನಾ ಕಲಿಸೇನಿ, ನೀವು ಒಂದಿಷ್ಟು ತಿಳ್ಕೊಂಡಿರಿ. ಈಗ ಮನೆ ಒಳಗೆ ಹೋಗಿ ನೀವು ಅಭ್ಯಾಸ ಮಾಡಿದ್ರೆ, ಅಭ್ಯಾಸ ಅಂದ್ರೇನ, ಶಾಂತ ರೀತಿಯಲ್ಲಿ ಕೂತ್ಕೊಳ್ರಿ, ಇಲ್ಲಿದ್ರೆ ಪೆನ್ ಪೇಪರ್ ತಗೋರಿ, ನಾ ಏನು ಹೇಳೇನು ಒಂದು ಸಮರೈಸ್ ಮಾಡ್ಕೊಂಡು ಬರ್ಕೋರಿ, ನಿಮಗೆ ನೀವು ಸ್ವಂತ ಬರೀರಿ, ನೋಡಿ, ಅವಾಗ ನಿಮಗೂ ಅದು ವಿದ್ಯೆ ಆಗ್ತದೆ. ಇವತ್ತು ರಾತ್ರಿ ನೀವು ಹೋಗೋದು ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಮನ್ಯಾಗ ಇದನ್ನು ಮರೆತು ಹೋಗ್ತದೆ, ಅದು ವಿದ್ಯೆ ಆಗಿ ಪರಿವರ್ತನೆಗೊಳ್ಳುವುದಿಲ್ಲ. ನಿಮ್ಗೆ ಹಸಿವಾಗೈತೆ, ನಿಮ್ಗೆ ಊಟ ಕೊಟ್ಟೇನೆ, ನೀವು ಊಟ ಮಾಡಿದ್ರೆ ನಿಮ್ಮ ಹಸಿವು ನೀಗಿಸ್ತೈತಿ. ನೀವು ಊಟ ಕೊಟ್ಟೆ ಅದನ್ನು ತೊಗೊಂಡು ಕಿಸ್ದಾಗ ಇಟ್ಕೊಂಡು ಮನೆಗೆ ಹೋಗಿ ಮಲ್ಕೊಂಡ್ಬಿಟ್ರೆ ಅದು ನಿಮಗೆ ಎನರ್ಜಿ ಆಗುತ್ತೆ. ಹಂಗ ಈಗ ನಾನು ಹೇಳಿದ ವಾಟ್ ಎವರ್ ಐ ಹ್ಯಾವ್ ಟೋಲ್ಡ್, if you simply go home and sleep, then you are going to get nothing. But if you work on that, work ಅಂದ್ರೆ ನಾ ಏನು ಕಲಿಸೇನಿ ಅದನ್ನು ವಿಚಾರ ಮಾಡಿ, ಆದ್ರೆ ಬರತ್ತೆಗೆ ಡೌಟ್ ಇದ್ರೆ ನಾಳೆ ಕೇಳಿ, ಅವಾಗ ಅದು ನಿಮ್ಮ ತಲೆಗಿರುತ್ತೆ. that will become knowledge. Your effort will get converted to knowledge, not my teaching. My teaching is not going to give you knowledge. It is helping you to gain knowledge. You have to help yourself. You are in 10th standard, right? So I hope you understood the potential difference between the two. Hello? Now when you take a battery, it has got two plates, positive plate and negative plate. Hello?
Yes, sir.
This is same like this plate and this plate. Here I told I am giving charge. In a battery, it produces charge. In a battery, there is a mechanism which will produce charge. It will produce charge and give it to positive plate and negative plate.
Yes, sir.
That mechanism, what happens is a chemical reaction. Just like how in a fountain, the water is coming out in a fountain and coming out like this. In a battery, the charges are coming out. And it is given to the plates. Got it?
Yes, sir.
Hello?
Yes, sir.
Now the beautiful part is, in a fountain, the water keeps on coming, whether you use it or not. But the beautiful thing in a battery is, the fountain will start only if the charges in these plates are depleted. There is one fixed amount of, see, this battery plate can contain, the potential difference between this battery is fixed. Say now 1.5 volt battery, the potential difference is fixed. Got it? To create 1.5 volts potential difference, hello? So if the potential difference between these two is 1.5 volts, then each plate will have how much potential with respect to earth? The potential difference between these two plates is 1.5. Each plate will have how much potential with respect to earth? Understood?
Yes, sir.
So that's how it gets 1.5. So this potential difference is maintained. Now you see, if you remove some charge from this body, what happens? The potential will decrease. Hello? Isn't it?
Yes, sir.
So same way from this plate, if you remove some charge, the potential will decrease.
Yes, sir.
It will be 1.5 volts. Slightly you remove charge, it will become 1.4999. Then immediately the chemical reaction will start and make it 1.5. Got it?
Yes, sir.
Now how does that happen? You will study in electrochemistry, which you will study in first year and second year PUC. You will study in first year and second year PUC, and some bit of chemistry is involved. I will teach you later on, not for this. But you understand this beautiful mechanism. So that is how a battery is made. That is how the mechanism in a battery works. Clear? Hello?
Yes, sir.
Right. Last. Now you can see here, I have connected this battery to a load. It can be a fan, a bulb or something. ये जो दिखा रहे हैं ना आपको, ये फैन भी हो सकता है, बल्ब भी हो सकता है. और मैंने बैटरी ऐसा टर्मिनल कनेक्ट कर लिया. ठीक है? अभी क्या होता है? पॉजिटिव प्लेट से चार्जेस निकलता है. अभी देखो ये कन्वेंशनल करंट का फिर से डिस्कशन मत स्टार्ट कीजिए. Actually, electrons will flow from negative plate to positive plate. But conventionally, current will flow from positive plate to negative plate. And so, I will say that positive charges move from positive plate to negative plate. But actually, physically, only electrons will move. If electrons move from left to right, we can consider positive charge moving from right to left. But physically, what is moving? Electrons. But notionally, conventionally, the positive charges are moving from right to left. Clear?
Yes, sir.
Now don't start a discussion. See, Mr. Aryan, there are some things to consider like this and proceed. It comes out. So like that, there are many things that we have to assume and move forward.
Yes, sir.
And you will understand. Clear? So here you see, the moment you connect battery, the positive current, the current will flow. Positive charges will move from positive plate to negative plate. Now actually negative charges will move, but conventionally we are telling positive charge. Okay. So the battery potential decreases for a very short duration. Then immediately internal mechanism will replenish the charges, and the battery potential is maintained constant. So though the current is flowing, charges are moving out of the battery. Okay, the potential between the battery terminals will remain constant. This is what is called as constant voltage source.